Hey PC fans, Gordon Allen with PCWorld, and I have a special treat for you today. One of the premier experts in power supplies, none other than Jon Gerow. Of course, you probably know him as the person behind JonnyGuru.com. He is at Corsair now making some of the coolest power supplies on earth. But what I want to talk to him about are all the things we are wrong about on power supplies, especially me. First thing, I hate modular power cables. Changed my mind.
Well, obviously the elevator pitch for modular cables is that you only have to use what you need, right? Cleans up the looks inside the computer.
Okay.
But one of the things I really like, especially now with so many people making custom cables, you can buy modded cables. You don't have to mod them yourself
All right, you got me
anymore.
there. You got me there.
And then, just taking this power supply right here, for example, it's made for SFX builds. So the cables that come with it are only 250 millimeters, long, not very long. But surprisingly, a lot of people take these and they put them in ATX builds. So they need that full length 550 millimeter cable. So they just switch them out.
Okay, you got me. I'm not going to say why I don't like them. I am in Jon's house here. As you can see, we are in Corsair's gaming lounge, so I am not going to dispute him. Let's get into actually more of the nuts and bolts of power supplies, though, because he has the brain on all of this. One of my first questions is, should I chase efficiency? Of course, we have 80 plus bronze, we have 80 plus gold, platinum, titanium, uranium, whatever.
Unobtainium.
Unobtainium.
Yeah. Well, from a green perspective, obviously, you're not going to feel as guilty, using a higher efficiency power supply. But your own personal ROI, you're not going to see. If you buy a more efficient power supply, even if you run that thing 24/7, you're not going. It costs more money to make that PSU. But what we like to do at Corsair is when we make a more efficient power supply, we also like to put in a little bit of value add to each of those models, make them better in some way. Again, referencing the SFX power supplies here in front of us, we have the 600 and the 750. The 750 is a platinum and the 600 is a gold. But what we do to make this a little more worth the extra cost rather than just the efficiency is we include the individually sleeved cables with it, and it includes a bracket to adapt it to an ATX case, right? Because those, in the grand scheme of things, are minor cost adders, but at least you're getting something out of it. Because if I was just to say, this is gold and this is platinum and this is going to save you like 2 cents a month on your electric bill, is that really going to be incentive for you to pay more money for the platinum power supply?
Sure. Yeah. And let's make sure for people who don't know what efficiency means, it basically means if I'm making, if it's a 600 watt power supply, if I'm at 100% efficiency, I would use 600 watts to make it, right? So as you get the bigger, more efficiency, you just use less energy to create.
Yeah, so it's whatever AC is not converted to DC turns into heat.
Okay.
Right? Which is another aspect too, of course, is that the if the PSU is producing less heat, the fan doesn't have to spin as much, it's not as loud. But again, we're talking about 1%, 2% differences, so it's very minor. So like I said, it's just nice to get a whole nicely rounded, better power supply overall. Is what we like to give people.
But definitely, if you care about the planet, you want to save it for future PC generations.
Look at California. They want system builders to use at least gold. Australia wants system builders to use at least silver, right? So they're forcing these efficiency requirements on us.
Sure.
Which is fine. I mean, because that's it's a whole part of the Protect the Planet initiative.
Yeah. What does it take to go from, say, a plus to a gold? I mean, is it better, higher quality caps?
Oh gosh, it's a it's a lot of stuff. So the core of it's going to be the design, right? Because you're going to need more caps to filter out more ripple if the design's not as good, and then those caps add some resistance that will reduce your efficiency. And then you have all the magnetics. So many things come into play with the magnetics. Your coil, your transformer, because all the power has to go through that. You have number of windings, the gauge of the wire, right? So if you have a lot of windings with a thinner gauge wire, obviously it's going to be less efficient than something with less windings and a thicker gauge wire, right? So a lot of stuff comes into play to make a power supply more efficient.
Okay, so it's not just a better sticker. Is what it is.
No.
No, I have a question. Are these single rail or multi-rail? Is that even a thing anymore?
It is.
Just too old school?
So the SF series is single 12-volt rail.
Okay.
All of our power supplies are single 12-volt rail, except for HX has a mechanical switch on it. You can choose between single and multiple. And anything that supports Link or IQ, you can change it in software.
Oh,
So
holy smokes! But is there any real reason to go with the multi-rail anymore? That was sort of a '90s thing.
Well, so 99% of the time, no, because it is a safety thing. Because what it is if the power supply is sending too much current down one particular connector or set of connectors, then you run the risk of all that current creating heat and possibly melting something, right? Now, most of the time, or probably only the time, nobody likes to say 100%, so let's say 99.9% of the time, that's only going to happen if there's a short, right? Assuming you're using the power supply the way it's intended and not running like a cryptocurrency mining machine where you've got 10 graphics cards running off a single SATA, right? So if there's a short circuit protection is supposed to kick in. But the wires that run to that short could act as a resistor, and then the short circuit protection doesn't necessarily kick in. So the power supply just keeps feeding power down the line, right? And that's when you end up with melted connectors or burnt components or whatever, when that does happen. So what overcurrent protection does, OCP, which is what your multiple 12-volt rail is just one 12-volt rail broken up into separate circuits, each with their own OCP, is when it sees that there's too much current going down that cable, then it shuts off the PSU. So and that's really the only thing it's for. But like I said, 99% of the time, short circuit protection kicks in. But there is that 1% of the time where it does happen, where somebody has a single 12-volt rail power supply. They pinch a wire in the side panel. The SATA connector cracks and the pins cross over, like 12-volt to ground or something. Or even something like their drive fries and it shorts inside the drive, and the power supply just keeps sending power to the short, right? And that's when you start seeing melted stuff.
But that's generally, would you say that's only going to happen in a power supply that isn't properly it's out of spec or maybe improperly designed?
No, short circuit protection can't cover everything. Okay. I mean, so yeah, the impedance of the short has to be less than 0.1 ohm, but if it's more than that, it'll just keep sending power down until it gets too hot.
Okay, now, so I'm going to ask you now, one of the tricks that I always do, I mean, I really believe if you're going to build a good system that's going to last a long time with quality components and you're not going to cheap out, you spend money on a good power supply.
Sure.
But if push comes to shove and it comes between a better CPU bin or one step higher graphics card, power supply goes overboard.
It's typically. That seems to be the case a lot of times.
Is that wrong?
Well, it depends on the power supply. I mean,
you're selling power supplies, so you're saying no, it's
wrong. For Corsair power supplies, I mean, we have a certain standard we set. We have a whole engineering team that makes sure that each power supply meets certain requirements that we put forward. But some of the lower end power supplies they used, like our VS series, they use an older topology. It's not as efficient. It has that efficiency curve that you keep seeing people use, where it looks like an arch. Whereas the more modern power supplies like RMX and stuff, they use a topology called LLC resonant, where the efficiency is pretty much a flat line, right? They produce less heat. They have more features like 0 RPM fan mode. And then you got the stuff where you can monitor it with Link, like the RMI and the HXI and the AXI. So, if you don't have the budget for it, I can understand using something like a CX. CX series is a great bronze power supply. And VS is great for a lot of the builds where, like if you're using the on CPU graphics or you have a lower end graphics card. The problem with the older topologies, and I'll say this for any of the power supplies that are out there that are still using 10-year-old topologies, is the modern graphics cards, they have such high loads so fast. We call them transient loads, right? That the older topologies can't keep up. And they just crash or make loud noises when they're in games or benchmarks and stuff because they can't handle it. So from my perspective, if you're using a newer topology PSU, like an RMX or even the CX, you're just going to have a better overall experience.
Okay. So, I mean, clearly at the high end, though, you're not going to have a problem because those folks are
Well, so that's just it, though. So, people are in the high end. They spent all their money on a 2080 Ti. They only have $40 left for a power supply, right?
Yes.
And I'm like, well, you probably should have waited a little longer before you bought that 2080 Ti, right? So.
Yeah, no, I mean, that's the tough thing, right? Because people, they don't want to match the power supply to go with the high-end hardware. So that's where it gets really dangerous. What about at the very low end, where you're just kind of using super cheap? Like when you're talking about CX series, to me, that's like fancy. Like some of these, I will do the free power supply in
Right,
some
right,
of our
right.
builds.
Oh yeah, the
'Cause
ones that
you
come in the
just-
cases and stuff. Yeah.
You know, because hopefully it's going to hold together. I know it's not the best.
Well,
but-
I mean, if it wasn't for the cheaper power supplies, I wouldn't have a job,
Okay.
right? Because the whole reason I got into this business was because I used to work in tech support, and we would see a lot of customers bring back motherboards that were just swollen caps, fried VRMs, and what we found was that either the voltage regulation was so bad on the power supply that the motherboard had to compensate a lot and often. The voltages were in range for the voltage regulators, but it can only handle it flopping back and forth so much. Or the ripple was so high, and the caps had to filter them out, and then the caps are swelling because they were. An overworked capacitor is the same as an overheated capacitor. Even if you're within the temperature range, it has the same impact on the capacitor. So I just got into it for that. When I found out what the problem was, through a lot of troubleshooting, I latched onto that because I was like, well, shoot, nobody else is doing this. Everybody's just building cheap power supplies and shipping them, and
Right.
nobody knows what they're getting. It's a box of mystery, of magic.
Well, and the classic story was if you were buying cases in bulk
Yeah.
with the power supply, they would say, do you want it with a 500 watt power supply or do you want it with the 300 watt power supply sticker, right? It's
The
just
sticker, right?
The sticker is the only difference. So.
And it's always the same 200, 250 watt power supply.
So that's like one of the sketchy things with power supplies,
Yeah.
especially low end ones, is the temperature that they are rated.
Yeah.
Is that still a thing?
Yeah,
Or
unfortunately
low
it
end?
is. And some of them will try to trick people. They'll put a operating temperature or operating range, right? That's the range in which the power supply can operate. That doesn't mean it can do its full load at the high end of that temperature. So they'll say operating temperature 0 to 50 degrees Celsius.
Okay.
But there's probably a D rate between 25 and 50 or 40 and 50 or 35 and 50 or whatever, and they never give you that information. So all of our power supplies are operating temperature 0 to 50. I think any power supply out there is operating temperature 0 to 50. But, is this going to do 750 watts at 50C, right? This will do 750 watts at 40C, right? And we tell you that. It does it at 40C. But not everybody will do that. They'll say, no, yeah, operating temperature, 0 to 50C.
Right, and the whole reason there is the rationale is if they don't tell you it's derated, it's actually, as it gets hotter, power supplies put out less power, and then, bam, you blow things up.
Right, exactly.
Huh, okay.
Or in some cases, everything just goes out of spec. Like the ripple shoots up through the roof, and voltages go down, and you don't know it, right? Because you're just using your computer. You don't have the equipment to check for that stuff.
Right. No, that is the hard thing. Is as a consumer, how do you find out if the power supply has good ripple, if it has that modern topology with that linear efficiency?
Yeah, you got to count on the professional reviews, and while the professional reviews can't weed out things like
JonnyGuru.com.
They can't weed out things like longevity because there's so much that goes into the design of the power supply that may or may not allow it to last 2 years versus 10 years, right? But they can at least put out there that we measured all the way up to full load at this temperature. The ripple was this. The voltage regulation was this, and so you've got that trust there.
Sure.
And then beyond that, I mean, like I said, you can't really test the longevity of a PSU in a test that only takes us like 2 hours to do.
Right.
So then you might want to look at the warranty, right? Well, it's got a 10-year warranty. They must have some faith in it, right? And if it dies in 8 years, I know I can get a replacement.
Here's another old school thing I'm going to ask you then. So, obviously, if you didn't have a really good review to rely on, or if the manufacturer wasn't forthcoming in specs, obviously 5-year warranty means, hey, they're going to be there for 5 years. The other thing was weight. It used to be oh, it's heavier, so probably, is that?
Not so much anymore because, like for example, this is dense, but it's not heavy, right? For a 750 watt, it's dense because it's small, obviously. But that's not so much the case anymore. It used to be when power supplies were relatively simple and they didn't have to meet efficiency requirements. But then when that suggestion got out there, they would do tricks like they would screw a concrete block to the side of the housing inside the PSU to make it heavier, right?
Giant, iron.
Or giant iron core. But with the higher efficiency, your heat sinks are getting smaller. That's lighter. Your magnetics are getting smaller. That's lighter, right? So if anything, power supplies are going to get lighter, not heavier. So it's definitely not something you want to look at.
So that old method doesn't work anymore.
No.
So the other one I've read though is some people say oh well, because I've always said one of the other ways is you buy a good brand with a good warranty that will
Right.
be there in 3 years.
Right.
Some people say, well, brand is not something you can rely on, which I don't. I understand.
Yeah, I mean, there's so many brands have so many different markets that they cater to.
Right.
That like India's got a very low price point, right? For example, just not to throw India under the bus, but as
Sure,
an example. So they will try to cater to multiple price ranges, and they'll do some things like rate the PSU is only good for full power 25C, or
So inside of an air
or it
conditioning
only works
version.
like 240 volt input, which means they can take the components on the primary side and literally cut them in half, because at higher voltage, half the current. So you can use cheaper parts, right? So it's really, a lot of people just hit to the forums. And what's funny is, there's always somebody out there that's taken one of these things apart. Guy might be in China, guy might be in Russia, Poland, whatever. But you can find those internal pictures and then throw them up on a website and say, hey guys, or Reddit, and say, hey guys, what do you think of this, right?
Okay. So that's a good way. Is you go post a photo of it to
Yeah,
power supply subreddit.
Yeah,
and
because a
people
lot of you can
analyze
just
it
look
for
in
you.
there and know if it's garbage or not.
Are these fanless? Or no, it's not fan. Just
It
no
does have
fanless.
the 0 RPM mode.
Okay. Yeah, and that's interesting because now a lot of people, there's some companies pushing fanless designs.
Yes.
Which I was a little puzzled by, because if you have a pretty good sized power supply, like my power supply, I know the fan is spun up in 4 years.
Yeah.
So
Yeah.
aren't they essentially fanless anyway?
Yes.
Do you need that fan?
Yes. I mean, more than anything, it's a liability for the fact that you are selling an 850 watt power supply, and an 850 watt, for example, it probably does need active cooling. So you don't want to just send it out there without a fan. Then again, there are fanless power supplies on the market that are 850 watt power supplies that they sell as 700 watt, for example, right? Because they know it can operate from 0 to 7 without a fan,
What do they count for high temperatures, though? I mean, how do you deal with 100 degrees summer
Yeah,
day?
really high, actually. It's surprisingly high. I've had reviewers push back and say, I hit this with a FLIR and this looks really hot here, and I'm like, here's the spec sheet. Look at the, do the thermal, the math, the life math on it, and you'll see that it's going to last the 10 years that we say it's going to last. And they come back and go, all right, you're right.
So you don't have to worry about the fans never turning on. Huh. So the other thing I want to ask you about is, again, I'm old school. I believe in the over-provisioning theory.
Right.
Of course, back in my day, it was 1,500 watts, 1,600 watts. These days, an 850 is almost like an over-provisioning power supply. That, for people who don't know, that is basically, you don't know how much hardware you're going to run, so you run a bigger power supply.
Right.
Just for insurance.
Right.
Is that a good idea or a bad idea?
It's not a bad idea, but it's not necessarily an economical idea. I mean, it's not a bad idea because you always have power, right? Just like you said, you're over provisioning. You're going to keep that power supply for 10 years, and who knows what NVIDIA or ATI or AMD is going to come out with, 5 years from now, right? It could be the next 295 X2. Who knows? That thing was a hog, right?
X4.
Yeah, right.
Two of them. And
Never got that daring, but we actually use two of them today still in the PSU lab to do real world stress testing. We'll just put two of them in there just to see what kind of noises you can get out of the power supply.
it was an awesome.
Yeah,
It was an awesome video card in the respect of power consumption.
Yeah.
So
But anyway, if you know what your wattage is going to be, there's no real reason to do the over provisioning because, like I said, the modern power supplies, or you could say the more expensive ones, do have that linear efficiency, right? So all your components are running well within spec, right? You're not getting that efficiency peak, at 50% load, which is a big thing everybody always points out is, you got to get a power supply that's twice what you need because your highest efficiency is at 50%, which isn't true anymore if you're using a modern power supply.
which costs more, by the way, too. Right?
Well,
as you're saying, like costs a
They're
little more.
coming down because more and more people are using that technology for their power supplies. It used to be that it was kind of an outlier technology that nobody used, but now everybody's starting to use it more and more.
So Corsair publicly states that the efficiency is linear, as you're saying.
Yeah. Actually, I mean, and it's not just take our word for it. You look at the 80 plus reports and also cybernetics. Cybernetics tests like a million different points of loads and calculates efficiency.
If I'm a consumer and I'm going out and cruising PC Part Picker, is there a way for me to see where would I find that data?
Yeah, that's a good question because they don't list that. And honestly, it's not. It kind of gets so technical that we don't even put it on our power supply pages, which tries to be concise. Again, the best thing to do is reviews.
Sure.
Because they're gonna point it out right away. Because as soon as they see the switching IC on the power supply, they're gonna go, I know what that topology is.
Okay.
So, and like I said, for us, it's everything that's CX and up uses, it's called LLC resonant. VS and CXM use the older topology.
Okay. So these are SFX,
Yep.
smaller than your standard HX power supply. This is 750 watts though.
Right.
Yeah, and it's a gold rated?
No, platinum.
Oh, platinum.
We could only do 750 if we were doing platinum. If we did it in gold, it would run too hot.
Oh, okay. Because the thing is 750 watts for a single GPU, single M.2.
Yeah. Well, when we launched this product, 750 watt was our sweet spot for power supplies. It's gone down to 650 watt, but it's still, for as cool as it runs because it's platinum, and the fan hardly ever spins. It's still a great power supply and a good value too. Like I said, we include the individually sleeved cables and the adapter bracket if you want to put in a regular case.
Do you think there's any reason to even go with a full-size power supply then these days? I mean, why not just use this? This comes with the bracket. You save some space in the case.
Yeah. Well, the power density costs more.
Yeah.
Right? I mean, so we had to use different parts. It's not like the PSU in the full-size ATX case is mostly empty space.
Yeah.
Right.
Yeah.
So you are paying a premium for the high density.
Okay. But you could just do it. I'm just wondering if
Absolutely.
we should, as an industry, think people are not needing the capacities anymore.
Absolutely. I mean, yeah, you could say this is the new standard, but like I said, that would make it, the whole cost structure go up.
Right, and people don't. As we know, nobody wants to pay more for power supplies, unfortunately. Even though it is a good idea. Last question I want to ask you, because I have had many power supplies blow up. I don't think I've ever blown up any hardware with it, though.
Good.
So, but is it just because I'm lucky, or do you find it more common in your lifetime experience to see those cheap-ass power supplies take hardware with them?
Well, I mean, mostly the cheap ones can and will because they lack certain protections, right, that prevent anything from exploding. Like if it explodes on the primary side, it doesn't go over to the secondary side, which is your DC, and screw things up there. If there's an explosion on the DC side, even a good power supply may not be able to protect it, because I have seen some cases. It's rare, but it can happen. It can happen. Voltages shoot up out of spec because a MOSFET decided to, crash and burn, then, there's only so much you can do. I mean, over voltage protection should catch it, but it's not an instantaneous catch,
Huh.
So
I'm trying to think of why I've always been so lucky. Maybe these power supplies are so cheap they don't make enough power in the first place to blow anything
well,
up.
I would have to say most of the time when a PSU blows up, it is on the primary side.
Okay.
And they are isolated from the secondary side, mostly by the main transformer, which is going to absorb most of the, most of any kind of surge or anything that goes through. So if it does pop and spark or whatever, that's why I said most of the time you're not going to have any damage.
Okay.
Yeah.
So generally not, but Murphy's Law is...
If it can happen, it can happen.
Goodbye, 2080,
Going back to the
2080
multiple
Ti.
12-volt rail thing, right? Like I said, only 1%, or not even 1%, but 1% of potential failures, right, which is within itself less than 1%, would need OCP to protect their hardware. But that's such a small percentage. It's just like...
Why chase it? Yeah, it's not worth it. Cool. Now I feel like I'm an updated power supply guy. I moved from my 1990s roots. Anyway, I just want to thank Jon Gerow again. Did I get it right?
No.
Nah. Once again, I want to thank Jon Gerow. Jon Gerow. Why is this so hard? Jon Gerow.
Gerow.
Once again, I want to thank Jon Gerow for Gerow. Okay, I'm going to... Okay, once again, I want to thank Jon Gerow for joining us. Once again, I want to thank Jon Gerow for... God damn it. Okay, here we go, one more time. Once again, I want to thank Jon Gerow for joining us. Come back to PCWorld.com and our YouTube channel to see more information from true experts like this. Thank you.
All right. Thank you, Gordon.